Hello, this is Dr. Morgan again at Clovis East High School. Today we want to go over the second lesson in the first week of our home study. We'll be looking at how to solve equations that have fractions and decimals in them. Our goal, of course, is to figure out how to get rid of the fractions and decimals to make the problem solving easier. So let's get started. First, let's do a quick overview of where we're going in these three lessons about solving multi-step equations. What we want to do is start and begin to form a series of simpler equivalent equations. We use all the properties of equality, inverse operations, and properties of real numbers to isolate the variable. Take this example. Notice that we have two expressions that are equal to each other. When two expressions are equal, we call that an equation. Now, to solve the equation, we want to start to isolate the x variable. We want to get that all on one side. First thing we do is we look at the left side and the right side. Remember, you can almost think of a line drawn down through the equal sign. Look on the left side and the right side and make sure we can simplify them as much as possible before we start going across the equal sign. In this case, there's two things we can do. If you look on the left, there's a grouping symbol. There's the parentheses, 3 times the quantity x plus 4. So we can use the distributive property to get rid of that those grouping symbols. So that's 3x plus 4 is 3x plus 12. On the other side, you notice we have like terms, 2x and 3x, so we can combine those. And you see now we've simplified the left side of the equation and the right side of the equation, and we're ready to go on next. Next, we want to get all the variables on one side. So in this example, I decided to get all the variables on the left side, so I have to get rid of the 5x on the right, so I don't combine it. I don't say 3x and 5x is 8x. Instead, I'm going to subtract 5x from both sides. Again, I have to, whatever I do to one side, I have to do to the other side. That eliminates it on the right, but then over on the other, I have 3 minus 5 or minus 2x plus 12 equals 8. Because I did the same thing to both sides, this next equation is still valid. Now we're at a two-step equation. So we undo the addition or subtraction first. In this case, we undo plus 12 by subtracting 12. And then we undo multiply by minus 2 by dividing by minus 2. And we end up with the answer x equals 2. So that's just a quick overview again of where we're going. So let's get started with fractions and decimals. First, let's consider how do we eliminate fractions from an equation. We've done this before, but if we want to simplify our calculations, we can clear fractions from an equation by multiplying both sides of the equation by the common denominator of the fractions. Now, just a reminder of how to find the common denominator. The easiest way that I know of, or the simplest way, is the following. If I want to find the lowest common denominator, I write a list of the multiples of each denominator. Notice in our problem we have denominators of 2 and 3, so I list this. Notice 2, 4, 6, 8, count by 2s, count by 3s, 3, 6, 9, 12. My least common denominator is the smallest number that's in both lists. And if we look at this, our smallest number is 6. So that's our lowest common denominator. So now we're going to multiply both sides of the equation by 6, and our fractions will be gone. Okay, so let's do the multiplication. 6 times x plus 2 and 6 times x plus 3 equals 5 times 6. So notice I'm going to do it the long way. Notice I recognize that 6 divided by 2 is 3, and 6 divided by 3 is 2. So on the left side, I have 3 times 1 or 3x, and then I have 2 times 1 or 2x equals 30. Combine terms, and now we can divide by 5, and our answer is x equals 6. So notice how by multiplying by the least common denominator, we ended up with an easier equation to solve that didn't have any fractions. So let's try the first problem on your worksheet. All right, here's our problem here. And as we said, we want to multiply each side by a common denominator. So our two denominators are 4 and 3. So once again, just like before, I set up a list 3, 6, 9, 12, 15, 18 for 3. Count by 4s, 4, 8, 12, 16, 20, and 24. And now what's the smallest number in each list? And it turns out to be the 12. So we're going to multiply both sides by 12. So as you can see, I use the distributive property now, and I have 12 times 3/4 x and minus 12 times x 1/3 x. Notice that I've written the 3x over 4 as 3/4 x, and the 1/3 x as 1/3 x, the x over 3 is 1/3 x. I also took the minus sign and put it outside here, but as long as it's in there, it's okay. Now I notice that 12 divided by 4 is 3. I'm just doing some quick work here. And 12 divided by 3 is 4. And so now I can multiply the numerators and have 9x minus 4x. 3 times 3 is 9. 4 times 1 is 4 equals 120. I could have done it another way here. I could have done 12 times 3 is 36 and then divided by 4 and got 9. And then likewise, I could have done 12 times 1 is 12 divided by 3 is 4. Now you see our result is we have an equation without any fractions. And now we can simplify it. In this case, we look on the left and we can combine terms. So I'm going to combine 9x minus 4x is 5x. Now I can divide by 5. Now undo the multiply by 5. And we end up finding out that x equals 24. And that's our answer. Once again, we can check our answer. I can put 3 times 24 over 4 and 24 over 3. And we end up with 72 over 4 minus 8, which is 18 minus 8, which does equal 10, which was our original equation. And so we know we did the problem correctly. Problem 2, you'll do on your own, although I'll give you a little hint here. Again, how do we get rid of the fractions? We multiply it by the common denominator. How do we find the common denominator? List multiples of the two denominators. So notice 4 and 5. There's my 4, 8, 12, 16, 20, 24, and my 5, 10, 15, 20, 25, 30. What's the smallest number? 20. So in this problem, I'm going to multiply both sides by 20. So good luck on this problem. A hint on this problem, you have 3 denominators here, a 9, a 6, and a 3. So make a list for each of them. 3, 6, 9, 12, 15, 6, 12, 18, 24, and 9, 18, 27, etc. And find the smallest number in all 3 rows. Good luck. Again on this problem, to eliminate the fractions, multiply by the common denominator. You have 2 denominators, 16 and 8. What's the least common denominator? Now, another problem that students don't necessarily like to do is problems with decimals. So we're going to show you a way to get rid of decimals in any equation, just like we did with fractions. We can clear decimals from an equation by a power of 10. Anytime you multiply a number by 10, the decimal point moves to the right. So first we want to find the greatest number of digits to the right of any decimal, and then we can multiply by 10 raised to that power. For example, here, look at all the numbers that I have in my equation. I have 75 hundredths, 3 tenths, 3 and 6 tenths. Now I just need to count the decimals to the right of the decimal point. Notice in 0.75 there's 2 places. Here 1 place and 1 place. I'm looking for the most decimal places. So in our case, the largest number of decimal places is 2. So I'm going to end up multiplying my equation by 10 2 times. Or you can look at it this way. Because the largest number is 2 places, I'm going to multiply it by 10 2 times 10 times 10. I can think of that as 10 squared, 10 times 10. Or I can just say I'm going to multiply by 100. Notice that my 100 has 2 zeros. That might be a way to help you too. I'm moving over 2 places, so I need one with the number of zeros. Okay, so we're going to multiply our equation by 100, both sides again. Now I use the distributive property, and I get 75. And notice here, when my decimal moves over twice on 0.3, it's not going to be 3, it's going to be 30. Likewise here, move the decimal on 0.6 over 2 places, it's going to be 360. And now we can combine terms, divide by 45, and we find out our answer is 8. So let's try it with our example on your worksheet. So in our example, We notice there's our given equation, but as I look at it, I see that I have the first number 3.5 is a tenths, and the 0.2, that's 200ths, and I also have 1 in 24 hundredths. So you can see the largest number of decimal places is 2 again, just like the example before. So we're going to multiply by 10 squared, or 10 times 10, 100, to remove the decimals. So we're going to multiply both sides by 10 squared or 100. And so we have 100 times 3.5 and minus 200 times x, and then 100 times 1.24. Distribute on the left side, and we get 350. Again, an easy way to multiply by 100 is just move the decimal over 2 to the right. And like in the first case, 3.5, if there's not a second number, you have to put in the placeholder 0. So 350 minus 2x equals 124. Now to solve this equation, we're going to use the subtraction property to subtract 350 from both sides, so I get my x alone. And now undo this by dividing by minus 2. Again, we're just working a two-step equation now. And we get an answer of 113. On this problem, we only have one number with a decimal, and that's the 2500ths. It has two places, so we would multiply by 100. You might be tempted at first to use the distributive property, 0.25 times d, and then minus 12 times 0.25. But you probably find it easier to multiply both sides by 100 first, and then do your distributive property. Check these numbers again. Count all the decimals to the right. You see that 0.5 is 1, but 2 in 325 thousandths, that's 3 places. So how many you're going to multiply by 10 3 times, or 1,000? I want to do a little reflection here. If you look at the problem given, I want you to consider how we could rewrite this equation with fractions instead of decimals, but solve it both with decimals and with fractions. So for example, here's my equation. 25 and 24 hundredths equals 5g plus 3 and 89 hundredths. If I were to write this as a fraction, this would be 25 and 24 hundredths, which I could write as 2,524 hundredths. 5 would be 500 hundredths, and 3.89 would be 389 hundredths. Now watch this as we work it. Let's do the decimal first. Okay, because of the decimal point, there's 2 of them, I'm going to multiply this equation by 10 2 times, or by 100. So I multiply by 100, and I get 2,524 equals 500g plus 389. So now we have a two-step, so let's undo the plus 389 by subtraction. And now let's undo the 500 times g by dividing by 500, and we find out that g equals 4.27. Now look what happens when I go over to my fraction problem. What's the least common denominator? Well, they're all the same. So I multiply the least common denominator, which is 100. Notice I've done the same thing to both equations, and I end up again with the exact same equation. 2,524 equals 50g plus 389. So now we're going to solve it the same way. So notice when we multiply by 100, when we're getting rid of a decimal, we're almost doing the same thing as if we just written it in fractions to begin with. So you can see they're very much similar. A decimal can be written as a fraction with a power of 10. So solving equations and decimals is very similar. So let's do a quick review of what we learned yesterday and what we're learning today. First, we started off by learning about two-step equations. What operation do we do first? Typically, we undo whatever is added or subtracted from the variable. So in this case, it's plus 3, so we undo it by subtracting 3. Then we undo, in this case, the multiplication. The opposite of multiplication is division, so we divide by 2, and we get our answer. We can always check an answer. Remember, when any of these problems, you can always plug your answer back in the original equation and see if you got it right. 2 times 6 is 12, plus 3 is 15, so we know we did it right. We also learned yesterday that one way to make equations easier when you're past the two-step stage is to combine like terms. So in this case, if I had this equation, first thing I would do is combine the like terms. I have two numbers with the same variable, 11n m minus 6m. I could rearrange them here and see them easier, but that combines to 5m. Now I have a two-step equation like above that I can solve. We also, if we see any groupings like parentheses, we want to get rid of them. And the way we do that is by distributing. So in this equation, I would distribute minus 8 times 2 is minus 16x, minus 8 times minus 1. Notice again, a minus times a minus is plus 8. Now I'm at a two-step, and we can solve it. Finally, let's review what we learned today. We learned first how to clear fractions. If we have fractions in our equations, we can remove them by multiplying both sides of the equation by the common denominator. Here's a sample equation. Notice our denominators are 3 and 4. How do we find the common denominator? Well, we list the multiples of 3 and 4. We find the smallest number, which is 12, in both lists. That's our common denominator, our least common denominator. Now we multiply our equation by that. Distribute. Notice that 12 divided by 4 is 3. So my first equation is to be 3 times 3 or 9. My second equation, 12 divided by 3 is 4. And 4 times 1 is 4. So I end up with 9x minus 4x equals 120. At that point, you could finish the problem by combining terms and then dividing by the coefficient of the variable. Second thing we learned today was how to clear decimals. If they're decimals, we can remove them by multiplying both sides of the equation by a multiple of 10 that matches the number of places to the right of the decimal. In this problem here, notice we have 3.5, 2 hundredths, 1 and 24 hundredths. So I have one place there, 2 places there, 2 places there. So my largest is 2 places. So I'm going to multiply this by 10 2 times. 10 times 10, 10 squared, or 100. So we multiply everything by 100. And notice when we do that, when you multiply by 100, it has 2 zeros, so the decimal moves over 2 places. So 3.5 becomes 350, 0.02 becomes just 2, and 1.24 becomes 124. Now we have a two-step equation that we can solve. All right, I hope this is helpful. We'll see you later.